I have another 6FQ7, but it's really weak, but at least I could swap it out and see if it follows the tube. Let's try that. I've swapped tubes and we could see that the problem still follows the tube to a different extent, but it could be some of the support components around the tube. So we're gonna have to take a look around there. I've moved my connections up here. This is just a logical connection that goes down to the finals input, and this is coming off of that phase inverter. This is what we're looking at on the channels, right? And we can see disparaging difference here, and the input is shorted on the phase inverter. The thing that gets me about this is if I remove the tube entirely, this goes away. So if it was coming through from DC through that capacitor, then it would still be there even if the tube is removed, and it's gone. So this is originating somewhere else. I've disconnected the phase inverter circuit from the finals. You can see that right here. I've just clipped them both. Got the oscilloscope connected there, right where the bias meets those finals connections. I want to show you what we're looking at, and I'll tell you the amp is dead quiet, right? There's nothing coming out of the speaker. And here's what we're seeing. Now, mind you, this is nothing. This is on 50 millivolts of scale, and these are about 1 high, so we're looking at about 50 millivolts. Now I'm going to flip the switch. And we can see that there's no change in standby, in or out of standby, shorting these two together, right? Which is what I would expect to see. When I move it to the phase inverter side, we get a different story. Now, mind you, there are no tubes on this phase inverter preamp side. We're just looking at what's coming in here. And if I slow it down, we get a better view here. There's definitely an imbalance here that we need to investigate. And by splitting these circuits in half, I'm able to see that it's not coming from the finals, but it is in fact coming from the phase inverter section here. The question is, given how there's no tube, and we're just looking at the outputs of these two capacitors, why is one significantly higher than the other? So we're going to investigate. And it does stand to reason. These are not symmetrical by any means, right? So we're looking at two entirely different circuits with two entirely different outputs coming out of this phase inverter. But we want to know what the problem is. We know that there's a common rail that's feeding it. We'll look at that common rail first, see what's going on, how it splits off, and see if there's anything wrong in between. There's really going to need to be an evaluation of all the resistors in this amplifier. Boy, oh boy. But just pointing towards where I'm working now, some of them were a little high, but two of them, the 68Ks especially, one in 68K was 103K, which is about double, right? And that's bad. But this 68K, I measured this like 5 times to make sure I was right. This 68K is 6.8 meg. Wow. Right? So I'm going to have to replace that one and that one immediately, and then I'm going to come back and look at this again. Here we go. I swapped out those two big offenders right there, 68K. They're both reading now 68K. I'm running it now. I've got the connection shorted together to the finals. I have the phase inverter is installed in the unit, and I have it out of standby, and boy is it quiet. You can see that I have some connections to those signals, and one is slightly off from the other. I haven't swapped resistors yet. I haven't gone through all the voltages, but I mean I've removed it easily. I've got it balanced easily by like 4 times what it was before, and removed whatever else was broken at resistor. If that resistor moved from 68K to 6.8 meg, you could be sure there's something else wrong. There's the mic right to the speaker, and we heard what it sounded like earlier. So it is improving, and we're slowly going to work our way back. I've resoldered those connections. It continues to be quiet, albeit slightly uneven, but getting there. I want to know what's causing this. There's like a little crackling, a little bit of lightning, and I have a good feeling it's probably in one of the resistors. You can hear a little tick every now and again. You can see it on the CRT, like the tick, tick. I think I'm gonna break out my other test set, see if we could localize it with that. You can hear the popping sound that's coming out of the coupling capacitor that's going to the final stages. listen to the other side. There is no hum on this side at all. There's just almost none. How do you like that? Here's pin 7. This is the input. Listen. Wonder if it's on pin 7 when the tube's removed. I took the tube out. I still hear it on pin 7. Trace it all the way up. I've got the signal tracer on noise mode, which means it's running voltage through both leads. It's not grounded, right? And I think I found the noise. Noisy resistor. The amp is off, by the way. Turn it up. This is only going through the resistor. So I think I've isolated it. Let me swap it out. I'll further point out that this 220 is showing 270, so ready to go too. There's going to be a reoccurring theme as I walk this back, but let's get this one out of here, solving for one noise at a time. So here we go. The snap and the crackle and the pop is gone. That loud hum is gone. Phase inverter is in right now. It's in operation. I've got the signal into the phase inverter is grounded, right? But the phase inverter is in. I'm going to bring it right up to the speaker. Hear a little bit of hiss. That's it. All that noise, all the artifacts, all the hum, everything's been cleared up. We're going to introduce 12AX7. To drive that point home, one last time, we're going to listen to that input on pin 7 phase inverter. It is totally quiet. There's nothing. No noise whatsoever since that resistor was replaced. That was making all that noise. And it was way out of spec. So good, moving onward. So I popped in a 12AX7, working it down one. I got 2 clamped to ground, right? So there's no input signal coming in. I could turn the volume all the way up and nothing's going to happen, right? If I take it off and hit the volume, right, you can see that works. So instead of having to worry about an input signal, all I'm hearing is any of the artifacts, right? And there are a lot, right? So I'm going to put it up to the speaker. And this sounds terrible. Listen to this. So I'm going to do a couple things. I want to check voltages on the 12AX7 first, and then I want to check for noisy components again. Voltage is supposed to be reading 93. We can see top and bottom. They're reading 146. Something's wrong here. I got to take a look at this. I've replaced this resistor right here, and I'll show you where it is on the diagram. It's the first one right here, this 68K that was originally replaced during that conversion. And it brought down most of the voltages almost perfectly within specification. There's a couple of outliers because of some resistors that have increased notably, right? So we can see a couple of them. 100 showing 92, 100 showing 88, right? But a lot of these are like 92 for 93, right? 225, 230, 100 for 105. That's like on the money, right? We look down here, 161 for 160, 55 for 58, right? And then I got, this one down here. This one's trouble, right? 166, 215, right? Look on top one here is nothing. Nothing at all. And as I'm going through this, right, I can see that it comes across this resistor, it comes across this resistor, and then it goes right to here. Now we know that we're getting voltage down here. What's going on? Let's take a look. So I'm on pin 1 right now, and we can see it's 166. Go across that resistor, as shown in the schematic diagram, where it would feed to pin 1. See, that's 337. Now, there's another resistor here that makes its way to pin 6, and that's this one over here. So I go to that resistor, which will in turn take me to pin 6. And I drop down to 4 volts. Wait a second. On this side of it, it's 300, and on this side of it, that's a hell of a voltage drop. I would like to know what the value of this resistor is. Yeah, that resistor climbed until my flute could no longer read it. I'm going to pull it out of the circuit. We're going to replace that resistor. Place that resistor. Now I go to pin 1 right here. And now on pin 1, I'm seeing 217, as I should. It says 215. Now I'll go over to pin 6, which is effectively over here. I also see 215. So replacing that resistor solved for that issue. V6 also showing low voltages. None of these resistors have been looked at yet, so stands to reason. I did find something up here I'd like to discuss right quick. So this is a 12AX7 pin 3. This is going through the resistor here. You can see those two resistors tied off. This is the cathode. I want you to hear it. I'm going to put this up to the speaker. Nice and quiet. This is using noise. The amplifier is off. I'm going to put it up to the other resistor now. You hear that? Sounds like the ocean. There's no tube in the socket, nothing. We're just talking about two resistors. Got another noisy resistor here. That could explain some of the noise coming in on the 12AX7. So we're going to swap that out. It sure is loud. I've gotten about all the hum out from this amplifier. I'm still hearing some more component noise though. You know, little by little it's being chiseled away as I make these repairs. It's still in there, and I think more use of the signal tracer is going to identify them in these resistors, and I think before the end of this project there's at least going to be several resistors more swapped out from this unit. Right, so here's the incoming voltage on this side, and here's the voltage drop. Right? Now, if I put the tube in, this is exacerbated, but you could still hear the noise, even though the voltage is significantly lower. Quiet as a church mouse, even though the voltage is twice. It's like 300 volts, and that's 100 volts. So, it could be, and that's crunchy. There's no tube in the socket right now, so it's going to nowhere. Right out of the socket. I wasn't even working on this one. Yep, here we go. Pin repair. Is it crimp and hold into place, like this being most popular for this particular pin size. I flatten the crimp just enough. You can see the crimp on this one. Flatten the crimp just enough to snap it up past the lock. We can see it released right there. Just push it up and out right there. Old tube sockets, when you need extra spares, there's a brand new pin. And we're just going to snap that right into the old socket. Here we go, just like that. We push it in. Then we're going to have to pull from the other side. From this side, I grab it here. Snap it into place. I can't recrimp it, so I just bend it outward a bit, and once I solder my connection, be good to go. Redo my connection. I've replaced the resistor again with a even quieter resistor. This is the before. Right? This was always quiet. And here's the after, which is louder, but no more artifact. Just a hiss. This heavily amplified, mind you. But it's just hiss now. So no more thunder. Very nice. And I will point out that this is sort of floating because I have the coupling capacitor disconnected. I wanted to hear what that sounded like. Just to make sure. So there's nothing feeding back from here. Nice and quiet. Let's reconnect it. Now we're listening to that output 12AX7. And it sounds really nice. Except for when my hand moves, because obviously it's just a probe. I'll bring you up to the speaker here. That's it, just a little hiss. Really good. Let's crank it up. Crank it all the way up. The probe introduces a little hum, but that's okay. That's it. There's no more artifact in there. No more noise. No more snare drum. It's all gone. We're going to take the amp out of standby and put it into operate. We've got the volume down here. Got the volume down here. Reverb is off. Amp is now super quiet. Unbelievable. I'm not even through all the circuits yet. But that's the 12AX7. That's the one with the high gain. What a big difference that made. Very happy with the progress. We're not stopping here. We're going to keep going. Quick functionality test while we're here. We'll flip on the reverb, which, by the way, on this amp is notorious for working even with all the channels all the way down. Absolutely amazing how this thing is sounding at idle. Sometimes you hit just the right location. And you can pick up the radio. Happens too. Finally, I'm going to check out those resistors up top, make sure there's no noisy resistors up here. Haven't seen the top in a while. Incidentally, here's the first tube shield that I've restored. This is one of the originals, and I've put that back on, if only to show it off, and the other ones I still have to do. Gone through and I've remeasured all of the voltages on the unit at 120 volts AC input, and I've annotated with a star things that I found to be off and only really came up with, and I did take my time with this. These two resistors right here, this first stage, this 12AX7, dropping this voltage really low here would reduce the headroom of this input. So I want to bring that back up to 100 volts. That's just fine. Take a look at those resistors. This other one right here, this 120 showing 83. An interesting note though, this is coming in off of this optocoupler, and you see, 164 coming in, goes through there, drops 83, 84, and that's the product. Really isn't a whole lot I can do there without raising the overall voltages of everything else. If the tremolo works just fine, shouldn't do anything as far as the sound quality goes. And it's a funny thing because everybody talks about capacitors and original capacitors changing the sound of amplifiers, and people will pay a premium for capacitors, which I think is snake oil. And nobody really looks at the resistors and how they climb and how the voltages change on the resistors that affect a variety of things. It has a profound effect on the sound of an amplifier and its characteristics. And both of these 220s are showing 270. I'll swap them out now. Swapped out those two resistors. We'll just remeasure this portion. A couple of volts off. I'm going to say that the voltage portion of this project is now done. We're going to bring the amplifier back down straight up and start with our signal testing. So the wife was here just before to help with some early C trials, right? And things sound good out of channel 1, no complaints. There's some artifacts still got to work out, but whatever. I'd like to get a couple of extra 12AX7s before I continue that. It's a different story. What you may hear right now is in channel 2, and I really didn't hear it until we were testing the reverb tank, and it took a while to isolate this. I have to be careful. Any noise I make sort of has this thing going crazy. Check this out. I was able to isolate it to make this noise come back. It was very difficult to find. I didn't know if it was in the guitar. I hit the strings with my fingernail to produce it. Found out exactly if it was from the guitar, if it was oscillating in here, and it turns out it's oscillating in the amp. Listen to this. And we can see as I turn it up, and this is the reverb, you can hear that frequency. That oscillation going on in here. And there's no rhyme or reason why I'm using treble and depth. It just happens to work. So if I lower the treble, it's subdued. You can still hear it. It's not affected by the volume, not affected by the bass, but it's affected by the treble, and obviously affected by the reverb. Shut off reverb. It appears to be gone. So it could be the reverb circuit feeding back into here, or something having to do with these two, most definitely. I have to find out what this is. So I'm gonna have to get this thing to oscillate and then trace it from the finals back and find out what's going on. So I've got my handy Heathkit signal tracer here. We're gonna come right off the connections for the grid and check this out. You ready? So I got the switch here. This for the tank, on and off. I'm gonna put it on this one, 2 different frequencies. That's one, that sounds like feedback. And here's the other one. And that was me turning the switch on and off on the reverb tank. So it's definitely the reverb tank. I got it back to there, and now we're just gonna walk this back to where that wet signal is injected back into the circuit. Here's pin 6 of V2. Now here's the thing. If I increase the volume, it'll feed back. Listen. it does sound like a feedback issue. Now knowing that it's feedback, let's do this again. Yeah, I could hear it feeding in. That may just be all it is. I may not be able to run that in this room with this amplifier open like this. It may be something that requires further testing in an open environment. These might be too close to each other. So here's what I did. I hooked up my little crappy 8 ohm test speaker, right? Does not have the fidelity of the full cabinet. I've got it pointed towards the wall away from this unit. And with that, I'm able to crank up this reverb, right? I got the treble up. That's all the way. I'll bring it back just a hair, right? Reverb up. And all the way up, you could just start hearing it all the way, right? So right there, it's fine. Remember, it's still an enclosed space. I've just improved the situation. I haven't gotten rid of it, right? The amp is still exposed and everything bounces off of the wall and then comes back into the amp. But now watch. It's not there. Here's another way that I inject a random noise into these amplifiers for testing. It's one of those crystal microphones. So I could go, this is a test 1, 2, 3, and then turn on the reverb. Test 1, 2, 3. Okay. Test 1, 2, 3. Test 1, 2, 3. Test 1, 2, 3. Now we get a little feedback over there. I'm going to be doing one last noise removal event of this amplifier. This time I have 8 ohm 100 watt resistor tied off to the output. So the amp has correct impedance match on the end, but there's nothing coming out of the amp as far as anything audible. It'll all be coming from the signal tracer at different segments. That way I don't need to put this into standby. And I'm going to work this all the way back through the different circuits and see if I could find anything at all that can improve this. Let it warm up. We're going to do this. We'll get started. There's some inherent hum to this unit that should be disregarded. We're going to start right here where it is coupled to the finals as the input to the finals. And we're going to see if there's any artifacts. We're listening for any thunder or noise. I know there's some in here. That's why I'm doing this. Yeah, I could hear some on this side. Check the other side. You definitely hear it there. We're going to work it back. The other side of the capacitor. Just so it's decoupled from the finals. I expect it to be the same. That's fine. They're both a bit noisy. The inputs are not noisy. 2 and 7 is quiet. I decided while I'm set up here to take the frequencies that are coming out of the phase inverter and hook it to the oscilloscope, and you can see them right here out of phase. Generally equal in amplitude. Looks pretty good. One seems a little more unstable than the other, the one in yellow. So I'm going to take a look at that one and see what's going on. We're going to bring this back up to pin 7 and 2 on the phase inverter and see if it follows the same issue as I bring that back. I might have found something coming off of this rail. I have this entire top circuit disconnected. We can see here, tied off to ground, the input. There's nothing going on up here. It's just no power. Only have power to the phase inverter. Both phase inverters have the same crackle. I'll just point that out now. All right. When I go to the outputs of the phase inverters, you hear all that crackle and what have you on there. Right? The input to the phase inverter is grounded. And I still hear this crackle. This one's got some hum. Now here's the thing. Here's the power off of the filter. And yeah, there's some hum on here because this is the filter off of the rectifier, and that's fine. But check this out. You ready? All you're hearing is hum, right? And that's okay. In this one instance, that's okay, right? But check this out. Let's come off the other side of that resistor. Let me test this resistor and see what's going on here. Maybe swap that bad boy out. That's noisy. Working upstream now, I've reconnected that resistor because I have clipped this connection going to the phase inverter, the one that I suspected. And even though I said it was on this side of the resistor, right, there's more than one thing connected to that pin. So not necessarily the resistor. And as a matter of fact, right, the artifact is gone with the resistor disconnected from circuit. There's this power distribution up top here, right? So here's the main distribution. Still quiet. Quiet as a church mouse, right? Distribution off of here, which was disconnected before. Here a little hum, but no artifact. And most importantly, the distribution to triodes. One. Nice and clean now. Number two. Turns out I was close. I'll split the difference here. The resistor that I disconnected for testing was not adequately connected back there. It was a bad connection, or touching something, or scraping something. And resoldering it fixed that problem. That noise is gone. And how gone is it? I'll show you. We're connected back into the amplifier now. And I'm going to press the camera right up to the speaker like we always do for testing through this project. Here we go. There's all the tubes in, everything running. That's perfect. There's no improving on this. I think this portion's done.